Today, we're going to talk about how to categorize numbers. So just like in science class, how we can categorize plants and animals into different kingdoms and species and families and all of that. In an art class, we can categorize colors. In ELA class, we can categorize words. In math class, we can categorize numbers to help us better understand them. All the numbers that you have experienced in life so far are known as real numbers. And yes, there are numbers that aren't real. You learn about those in algebra. Real numbers can be broken down into two smaller categories. Rational numbers, which are numbers that can be written as a fraction, and irrational numbers, which are numbers that cannot be written as a fraction. Now, rational numbers can be further split up into three smaller categories. Integers, which we've talked about before, whole numbers, and natural numbers. So we have these three categories of rational numbers: natural numbers, whole numbers, and integers. Natural numbers are counting numbers. They don't include zero. So let's say you can't sleep at night and you decide to count some sheep. You start with 1, 2, 3. Those are natural numbers. Whole numbers include all natural numbers, but we also add in 0. So 0, 1, 2, 3, and so on. Integers include whole numbers, but we also have all of the negatives as well. Let's look at a diagram that might help make sense of this. So we're starting off with real numbers, and we can divide real numbers into two categories: rational and irrational. Irrational numbers cannot be written as a fraction. So for example, pi is an irrational number. A square root that isn't a perfect square would also be an irrational number. So for example, the square root of 3. If we look at rational numbers, let's start with the smallest subset, natural numbers. These are whole numbers, but we don't include 0. So they're counting numbers: 1, 2, 3, etc. Next is whole numbers. Whole numbers, we just add in the 0. Notice that if a number is a natural number, it's also a whole number, because that circle for natural numbers is included inside of the circle for whole numbers. Now if we add in negative numbers, we get integers. Notice that if a number is natural, it's also an integer. If a number is a whole number, it's also an integer. Lastly, the broad category of this section is a rational number. These are numbers that can be written as a fraction. Notice that if a number is natural, whole, or an integer, it's automatically a rational number. Let's look at some examples. So if we have negative 21, negative 21 is a real number. It's rational because it could be written as a fraction, negative 21 over 1, for example, or negative 42 over 2. It's also an integer because it has a negative sign and it's a whole number. If we have 0.15 or 15 hundredths, that's a real number and it's rational because we could write it as a fraction. 15 over 100 or 15 hundredths. Obviously, we would want to simplify that, but it can be written as a fraction. Lastly, 0.15 repeating. This is a real number and it's rational. Even though it's a funky decimal that goes on forever, we can actually write that as a fraction, and we're going to learn how to do that in a little bit. Next, we have 5 sevenths. 5 sevenths is a real number, and it's also a rational number. Obviously, it can be written as a fraction because it's given to us as a fraction. The next one, the square root of 4, is actually real, rational, an integer, a whole number, and a natural number. So it's a lot of things. The square root of 4 is actually 2 in disguise. So it's rational because it can be written as a fraction. It's an integer, it's a whole number, and it's a natural number. Our last example of categorizing numbers is the square root of 5. So this is a square root that cannot be written as a perfect square. So therefore, it's real and it's irrational. So now let's look at some examples of converting some repeating decimals into fractions. So if we take 0.3 repeating and we want to write it as a fraction, you may know what that is already, but let's practice this to learn the process. So first, we want to define an equation that we can use to help us find the fraction. So we're going to say that x equals 0.3 repeating. Now there's one digit that's repeating, so we're going to take our whole equation and we're going to multiply it through by 10. So when we do that, we get 10x equals 3.3 repeating. Remember, when you multiply through by 10, it just moves the decimal place one spot to the right. Now that we have that, we want to get rid of the part that's repeating. So to do that, we're going to subtract our original equation. So we're going to subtract x equals 0.3 repeating. When we do that, it cancels out the repeating part of the decimal. So that leaves us with 9x equals 3. Now we have a simple equation that we should be able to solve. We want to divide both sides by 9, and that gives us that x equals 3/9. We can simplify that fraction, so we get the fraction 1/3. Let's look at another example. If we wanted to write 0.25 repeating as a fraction, we want to start off by just saying x equals 0.25 repeating. Now there are two decimal places that are repeating, so instead of multiplying by 10, we want to multiply by 100. So when we do that, we get 100x equals 25.25 repeating. So we're just moving the decimal place 2 spots to the right this time. Now again, we just want to subtract our original equation that we started with. So we're going to subtract x equals 0.25 repeating. And when we do that, we get 99x equals 25. The repeating part of the decimal canceled out. Now we have a simple equation we can solve. We're going to divide both sides by 99, and we get that x equals 25/99. Since we can't simplify that fraction, that's our fraction. That's our solution.